on June 2nd. We know theoretically you'll have 1 week of time to get your to accept the request. If you don't do it, the request will get expired. All right. So this is the information currently. Private IP is disabled. DNS resolution from local VPC to private IP is disabled. So the cross VPC communication DNS resolution is actually that's pretty much it. How can you accept a, since it is your own account, you just right click it, and you can also edit the DNS settings and you can allow the name resolution to happen, but that's fine. We are not in a situation to understand the name resolutions, but we just wanted to understand the communication. Okay, say accept the request. Yes. Now we turn active. The peering connection name is this. This is the connection name that you have to use anywhere to enable the communication or anything. Okay, now I just copy it. I go to VPCs. Yeah, before I tell you that, now we've created the VPC peering. Still the communication is not happening. Why do you think is not happening, and what changes need to be done? I go to anybody, please. What do you think need to be done in our situation to enable the communication between these two VPCs? We have created the VPC peering connection and it is active. What else need to be done? It's clear that the communication is not happening.
We need to allow it in the route table, the other one, IP address.
Okay. Devendra, seems you are perfect with the topic, so I believe you don't have to retake the course. Don't you think it's so? Never mind. I'm just kidding you. Yeah, I'm just kidding you. You can retake it, no problem. So route table, and what is a route table? That is actually part of the QA. This is the one, because there are two subnets that are part of this route table. Now I go to routes here, and you see if the destination is this, you route it locally. If the destination is the internet, you route it to the internet gateway. If the destination is 172.27.00/16, then you route it to this PCX 3343CF5A def. Save it. Okay, so I'm going back here, no response. I'm going back here, still no response. What else need to be done? What else? What else need to be done?
Subnet association.
Well, I go to VPC peering here. So far, we have just sorry, route table. Yeah, we've just modified the QA VPC route table. You also have to edit the dev route table here. If the destination is 10.0.0.0/16, you forward it to the same PCX. Okay, so save. So now we have edited both the route tables to forward the packets to the respective things. So let me go back and say restart the session. It's EC2 user, and I say ping this IP address. You see, now I am getting the response from 172 machine. I am actually able to reach this 10.series. Similarly, let me go to this 172 machine. Same, restart the session because it was a timeout. The session got user. Yeah. So now the ping this IP address. You see, I'm getting the response. Okay. So practically, we are able to reach from this VPC, the test, the QA VPC, to the development VPC and we are able to reach. You certainly can do the name resolution, and you can bridge any kind of communication with the help of routing and the help of route tables and the subnet association and all that stuff. You can see that there are two subnets associated with this particular route table, and explicitly, though you don't explicitly associate, I told you it is a main route table for dev VPC. So these subnets will fall into it, or else you can explicitly add them, not a problem. You can explicitly add them, but even in future, if somebody can, there's a possibility that people may ask you during the interview. So to avoid that, you can explicitly add them, or if you don't add subnets to any route table, they by default fall into the main route table of the VPC, right? So you need to make necessary changes in the route table. It's the powerful thing. Though you configure everything else perfectly, but you fail to configure your route table properly, that's when the communication will not happen. So route table is a key thing here, that it will actually tell the VPC how to forward the traffic. You see, when the destination is this IP address, it routes locally. When the destination is this, it forwards the traffic to internet gateway. And when the destination IP address is anything that fall into 10.0.0.0/16 IP address range, that it forwards the traffic into this particular connection. Okay, so this is how you basically enable the communication between the VPCs. And if I go to endpoints, the other day I was telling you that you can create an endpoint that is a private communication between the S3 buckets and the services. I say create endpoint, select a VPC, let's say dev VPC, select a service. Currently it is only supporting S3 service. I just have to select it. You can specify if it is a full access or a custom access that you wanted to give. Let's see, full access. Next, which route table should it be part of? So as per the VPC configuration, this is the only route table that we have, and you say create endpoint. Boom. The endpoint has got created, and whenever you wanted to communicate to this endpoint, the communication will happen to your S3 local, North California S3 region. It will happen within the VPC, and it will be the very fast network communication is what happens. All right, and then you all must be wondering that Venkat, it's fine, right? It's really a good theory that you've actually explained us, and it was a detailed practical too in VPC and in all other components. One thing I still, I'm not clear is the NAT instances or private subnet and NAT instances. How to take care of it? 1 second, guys. I'm coming. So, how to create the private subnets is a question now. Well, there is no separate wizard to create a private subnet. You just go here, then create a subnet, okay, and you give a name to it. Maybe yes, create a subnet, and I wanted to say it's PRI private, and yeah, this is the VPC. It may be 1B availability zone 172.27 2.0/24. Okay, you may ask me a question, Venkat. It is the same wizard that we followed to create a public subnet, and it is the same wizard that we are following to create a private subnet. What is the real difference between them? Well, one difference is, let me bring out an image so that I can explain you better. So here, if you see, yeah. So do you see this particular image wherein you have a public subnet and a private subnet? Okay, the public subnet IP range is 10.00.567, 3 IPs, whereas the private subnet IP addresses are 10.01.567, right? So here it is 0, here it is 1. That's the only difference. Otherwise 567, 567. Now, if a machine in the public subnet wanted to communicate to the internet, the machine will directly go to the route table, from there to the internet gateway, and that's all. Okay, but here in the private subnet, a machine has to go to the route table, then it go to the NAT instance. Okay, from the private subnet it goes to the router, from there it goes to the NAT instance, and the NAT instance is connected to the public subnet, so from there it goes to the internet. That's the only difference. For public subnet, you directly let it communicate to the internet gateway. For private subnet, you ask it to communicate to NAT instance, and then you go to internet gateway. So that way you will mask your IP address. That way you will mask your IP address. And if you actually look at the main, if you actually look at the route table on how the routing is actually configured, if you see, if the communication is local 10.0.0/16, then you route it locally. When the public communication it is 000, you forward it to the internet gateway. In case of the private subnet, you see what's happening here. In case of the local 10.0.0/16, it's the local. It's the same entry in both the route tables, but the entry for 000, you're forwarding the traffic to NAT instance ID, which is this. You're asking the traffic to go to the NAT instance, and from there NAT instance will forward the packets to the internet gateway and to the internet. Hope it is clear. Now that you have created a subnet here, okay, and you have to go to the route table and add an entry here. Sorry, you have to go to route table and you will add an entry, but before that we need to have the NAT instance set up. Okay, so how can you set up a NAT instance? Is by going to the EC2 instances, and you can launch a instance. You go to AWS Marketplace and you search for a NAT instance, right? Cisco's NAT instance servers are available. The virtual routers are nothing but the NAT instances, and there are many available. Or else you just can go to VPC and there is a NAT gateway available. Create a NAT gateway, and this NAT gateway is for what? Let's say this is for the dev VPC. And Elastic IP, create a EIP and create a NAT gateway. And now you the NAT gateway is being created. This is a NAT ID. We just have to go to the route table again back and then edit the route table to forward the traffic to this NAT instance. Okay, so how can you do that? Well, it's created for the dev VPC. It's the VPC ID BC0. I go to this, the dev VPC, and the NACL. This is the route table. You create one more route table here, and it is a private subnet dev create, and this route table, sorry, this is the one. Okay, so in that you say edit, add role. Whenever the destination is this, you forward this to NAT instance, you see. Okay, save, and you need to make the right subnet association. You make sure the private subnet is actually associated with this particular route table. Make sure you only associate your private subnet with this particular route table, or else if you kind of pull out, let's say you can also pull out the other subnets here. Okay, you can do that. When you do it, subnets will be pulled out of the other route table, which is actually allowing the public communication will come here. It will never throw out an error saying, hey, these public subnets are already part of a route table. It will never tell you. Rather, it will just pull out those subnets from the other route table and put them in here. So make sure that you only assign the private subnets to your route table which is actually configured for the NAT instances. If it is a public, public subnet, for this entry you will find IGW over here. That's the only change. Okay, so I go to dev, the subnets, edit, then I'll be pulling those two public subnets over here. That's how the default configuration must be. Got it? Now we have created a public subnet, a private subnet, and private subnet have got its own NAT instance and the route table. A public subnet has got its own internet gateway and your route table. Okay, so NAT instance and the route table, internet gateway and the route table. The machines can communicate respectively. If I go to EC2 management console, you launch a machine, launch can be the same, the free instance. Here it is again, the dev VPC. I can say the private subnet, right? And you don't need a public IP for that, because a communication will be forwarded to from this mission. The communication is forwarded to the NAT instance, and from there the traffic is forwarded to the internet. So you don't need a private IP address, sorry, public IP address, IAM rules and all. It's all the same. The only change was to use the internet gateway. Okay, so alternatively, when you are actually creating a VPC, when you say VPC with public and private subnet, it will ask you to create a NAT instance here itself. You see, there is no NAT gateway available, so use a NAT instance instead, right? You are deploying an EC2 instance here, and you can set up a key pair also. So there will be a NAT server that get deployed. There will be a NAT server that will get deployed, and it should be ready for you. It is just an EC2 instance that get deployed here with the NAT role installed. Okay, so creating a NAT instance is part of the VPC creation wizard, and it is also kind of, you can go to VPC management console, go to the NAT gateways here, and you can create it. Either way it works. Either way it works. All right. So that is pretty much about your VPC, guys. I believe it is like clear explanation. Any questions? Any questions? No? Fine then. I'll see you tomorrow with maybe IAM topic, identity and access management. Okay.
Venkat, can we see how the traffic is routed through NAT instance?
It's the same way,
like
basically.
Okay.
So when you are choosing the NAT instance, that means from the external world, you will not be able to communicate to the mission because you do not have a public IP. Okay.
Okay.
But from the EC2 instance, you should be able to talk to the internet. You try that. If you see any issues, I'll help you. Because as a matter of fact, you know, right, there are many other things and we cannot practice everything out in the classes. You try things out the same way that I explained you. And if you face any issues, I'll help you out.
Okay, fine.
So fine then, I'll see you tomorrow then, at the same time.